Good day, everyone. I am Hannah Bella Arceño, and together with my partner Carmela Castro, we are here today to present to you the study entitled Earthquake Damage Prediction from Satellite Images Using Gradient Boosting Algorithm with Decision Trees as Base Estimator. The study was conducted by Donata D. Acula. Here is the outline for our presentation. And to start, here is my partner Carmela Castro.
Thank you, Hannah. For the motivation of the study, the Philippines experiences an average of 20 earthquakes every day and 100 to 150 fells every year. However, PVOX only detects the damages of earthquakes using satellite images by measuring if there is change or no change in the location of the earthquake. And currently, the Philippines has no existing tool to categorize the level of earthquake damages based on the satellite imagery. The earthquake damage prediction was explored to detect the earthquake damages from satellite images and classify them using AI. For the materials and methods, we have the framework of the process. For our dataset, we have 23 satellite images from the earthquake in Eastern Summer in 2012, and we have two training datasets, the images with and without augmentation. For data augmentation, the first group includes images without augmentation, and the second group includes segmented images through rotation, shearing, and clipping. So augmentation was used to create new images from existing images. After augmentation, features of the images were extracted. The extracted features per image are around 14 million, which will serve as the predictor of the gradient boosting classification algorithm. This study used 20 to 80, 30 to 70, and 40 to 60 for testing and training data, respectively.
The next phase is the detection or classification, which involves decision tree classifiers and gradient boosting algorithm. The decision tree classifiers were used in extracted features of the satellite images to select their best attributes recursively, and split data and expand nodes of tree until the required condition was satisfied. The gradient boosting algorithm involved a loss function, a weak learner that will serve as predictor, and the additive which will be added in the weak learners to minimize the loss function. To note, the n estimators was experimented by using the values 10, 20, 30, 40, and 50. And then after detection or classification, we will now have the classified images, which were labeled as with or without earthquake damages in the study. For evaluation, first, our hypothesis was to determine if there is no significant difference between the actual and classified output, and the classification metrics that were used were confusion matrix, accuracy, precision, recall, and F1 score. The hypothesis will be rejected if the experiment obtained a 100% accuracy rate in detecting earthquake damages. For the results of the discussion, first we will discuss the results of classification using GBA without augmentation. The most promising results can be found in the Table 4 of the study. The optimal model for detecting the earthquake damage from unaugmented satellite images is the gradient boosting partition 30 to 70 for testing and training respectively with an estimator of 30. As seen in Table 4, the metric scores were all 80% and above. Secondly, we discussed the results of classification using GBA with augmentation. And as seen, tables 8, 9, 10, and 11 showed promising results. The gradient boosting algorithm with n estimators of 20, partition 30 to 70 and 40 to 60 in table 8, n estimators of 30, partition 20 to 80 in table 9, n estimators of 40, partition 20 to 80 and 40 to 60 in table 10, and n estimators of 50, partition 20 to 80 in table 11, garnered the best classification with metric scores of 100%. From this, the best partitioning is 20 to 80. For the conclusion of the study, employing data augmentation in satellite images before and after an earthquake significantly improves machine learning models. Based on the results, there is a significant difference between the actual and classified output with augmented images. Next, gradient boosting algorithm is an efficient and powerful classification algorithm in detecting the earthquake damages visible in satellite image data. And then lastly, pre-processing and classification techniques such as image augmentation, decision trees, and gradient boosting algorithm can be used in other field studies involving image analysis, such as in handwriting recognition and medical images classification. And that would be all for our presentation. We are now ready for your questions.